Good morning, students. Hello, everybody. Today I am going to continue the same chapter, that is arithmetic progression, which we have started earlier, and there we have learnt about the basic concepts of arithmetic progression, the general term, the general form, and solve few problems from there. So today also I will solve few problems based on the general term of the AP. Here's the first question. It says that if the nth term of an AP is 5n minus 2, then find its first term, the common difference, and the 19th term. Okay, so the general term is given as 5n minus 2. Let me write down the question. If the nth term of an AP is 5n minus 2, then find its first question is the first term, second question is common difference, and the third question is the 19th term. Okay, so let me take the nth term as an. An is equals to 5n minus 2. Now let me take n as 1. So if I am taking n as 1, then a1 equals to 5, n is replaced with 1, so 5 multiplied with 1 minus 2. So how much is this? 5 minus 2, that is 3. Now what is a1? a1 is the first term. Okay, so we generally used to represent the first term as a, and here it is a1. So the first term is 3. Now let me take n as 2. Let n equals to 2. So n is replaced with 2, so it becomes a2 is equals to 5, then n is 2 minus 2. So it is 5 multiplied by 2 is 10 minus 2, that is 8. Now what is a2? a2 is the second term. So second term is 8. Now let me take n as 3. n equals to 3. So it is a3. a3 means the third term. a3 equals to 5. n is replaced with 3. So 5 multiplied with 3 minus 2. So it is 5 multiplied by 3 is 15 minus 2. That is 13. So we have got the first three terms, a1, a2, a3, and the AP is the first term is 3, the second term is 8, and the third term is 3, and so on. Okay. Now from here we are going to answer the questions. The first question was find the first term. So what is the first term? Question number 1. Answer for the first term. The first term is 3. Second question is to find the common difference. Now how to find the common difference? Common difference is equals to a2 minus a1. So a2 is 8 and a1 is 3. So 8 minus 3 is 5. Therefore the common difference is 5. And the third question is a19. So a19 is a plus 18d, as I have told you just now, a plus 18d. So a is 3 plus 18, d is 5. So 3 plus 18 5s are 90. So the answer is 93. So we have got the answer of all the three values, all the three questions. That is, the first term is 3, the common difference is 5, and the 19th term, that is a plus 18d, is 93. So just quickly go through the solution. The general term, the nth term was given as 5n minus 2, so it is an equals to 5n minus 2. Then I have taken n as 1, so it becomes a1, that is the first term. After calculation, I have got the first term as 3. Then I have taken n as 2, n equals to 2, so it becomes the second term a2, and that is n is replaced with 2, so I have got a2 as 8. Similarly, n is replaced with 3, so I have got the third term a3 as 13. So I have got the ap as 3, 8, 13. Okay, that is, I have got the first term. Common difference is a2 minus a1, so a2 minus a1, 8 minus 3, that is 5, and the 19th term is a plus 18d, so it is 93. Okay, so isn't it very easy question? Yes. So in this way we can apply our basic knowledge to solve this type of sum. Okay, now let us go for one more question. The question is, if m times the nth term is equal to n times the nth term, then if n times the nth term is equals to n times the nth term, then show that m plus nth term is 0. Then show that m plus nth term is 0. M is not equals to n. The condition given is m and n are not equal. So once again the question, m times the nth term is equals to n times the nth term. Then show that m plus nth term is 0. So first of all, let us form the equation with this. M times the nth term. So it is m times the nth term. We generally used to take the nth term as am. This is equals to n times the nth term. N times the nth term. So n multiplied with an. Now let us put the general values which we used to take for am. What is am? Am equals to a plus m minus 1d. The general form of an AP. Similarly here also n multiplied with an. An is a plus n minus 1d. Okay. Now see, this a is the first term and d is the common difference. Here m is the number of term of this AP and n is the number of terms of the same AP. Now let me simplify this first. A plus this d and n multiplied, so it becomes dm. dn minus 1 is minus d is equals to, here also a plus n and d multiplied, so it becomes nd, and minus 1 into d is minus d. Now let me open the bracket by multiplying it first. This is am plus dm square. M into a is am, m into dm is dm square, m into d is minus dm. This side also n into a is an, n into nd is n square d or dn square, and n into minus d is minus dn. Now let me take all the things to the left hand side, making the right hand side 0. So am minus an will become to the left hand side, it will become minus, plus dn square will come to the left hand side, it will become minus, so minus dn square, then minus dm, this minus dm will go to the left hand side, it will become plus dn, and right hand side will become 0. Okay, so this is m minus n is common, plus here d is common, so it will be m square minus n square, and here also d is common, so it will be m, this plus will become minus, as I have taken minus sign outside, n equal to 0. So m minus n plus d, this is m square minus n square, so it is m plus n multiplied with m minus n, m plus n, m minus n minus d, m minus n equals to 0. Now see, in all these terms m minus n is common, so let me take m minus n common. So from here it will be a, from here it will be d m plus n, and from here it will be minus d only. I have taken m minus n common from all the terms. So from here it is a, from this term m minus n is taken common, so it will be d m plus n, and here m minus n is taken common, so minus d will remain here. Okay. Now the next. It was given in the question that m is not equals to n. This is very important condition. So now this can be written as m minus n, and here a plus. See, in both these terms we can take d as common. So if d is taken common, then it will be m plus n minus 1 multiplied with d. See here, I have taken d common. From here d is taken common, so m plus 1 will remain here, and from here I have taken d common, so minus 1 will remain inside the bracket. Okay, and right hand side is 0, which implies m minus n. Now what is this? The whole thing. Just see. Can we write this as m plus n? This is m plus nth term. Just compare with the general form. Nth term is a plus n minus 1d. So here m plus nth term is a plus m plus n minus 1d. So this is nothing but the m plus nth term equals to 0. So now we have got two factors. We have got two factors, either m plus n, m minus n equals to 0, m minus n equals to 0, which implies m equals to n. But this is not possible. Why? Because it is given in the condition that m is not equals to n. Therefore we cannot take this. Therefore m is not equals to n. We cannot take this. So what is the other condition? The other condition is m plus n equals to 0. That is the m plus nth term is 0. That is what we have to prove. We have got two factors, either m minus n equals to 0 or a m plus n equals to 0, that is mth term equals to 0. So since the condition given is m not equals to n, so we cannot take this. So this is obsolete. Therefore a m plus n equals to 0, that is m plus nth term is 0. So this is also proved. Okay. So in this way, just simply follow the basic concept. You can solve any problem. Okay. The last one, the next question. If the pth, qth and rth term of an AP B, A, B and C respectively then prove that A Q minus R plus B R minus P plus C Q minus P, sorry P minus Q, C P minus Q equals to 0. If the pth term is A, qth term is B and rth term is C, then prove that A Q minus R plus B R minus P plus C P minus Q equals to 0. So first of all, we have to find the general form of pth term, qth term and rth term. The general form of the pth term AP is equals to x plus P minus 1D, and that is given as A. Here I cannot take the first term as A because the pth term is given as A. So I have taken the first term as x. Similarly, the qth term, it will be x plus q minus 1D, and this is given as B, and the rth term x plus r minus 1D is equals to C. So here I have got the general form of pth term, qth term, rth term, and their values are A, B and C respectively, and we have to prove that A is Q minus R plus B R minus P plus C P minus Q equals to 0. Okay. So let me simplify all this from here. So it is let me put the value of A in the question. So left hand side will be A means x plus P minus 1 multiplied with D. Value of A is this one. So x plus P minus 1 B, A multiplied with Q minus R. So here is Q minus R plus B. The value of B is x plus Q minus 1 D multiplied with R minus Q plus C. C means x plus R minus 1D, x plus R minus 1 D multiplied with p minus q. So this is the left hand side of the question. After simplification, it will be x plus p multiplied with d is pd minus 1 multiplied with d is d. Similarly, it will remain as it is plus x plus q multiplied with d qd minus 1 multiplied with d is minus d into r minus 2 plus x plus r multiplied with d rd minus 1 multiplied with d minus d multiplied with e minus d. Now I have to simplify the whole thing. Okay, so starting with the first one, x multiplied with q, x cube, x multiplied with r, xr, pd multiplied with q, pqd plus pd multiplied with minus r minus prd minus d multiplied with q minus dq minus d multiplied with r plus dr. Okay, so the first part is finished. Now the second part, x multiplied with r, xr plus minus x multiplied with p, so minus xp plus qd multiplied with r, so qrd minus qd multiplied with p minus pqd minus d multiplied with r minus dr minus d multiplied with minus p, so plus dp. Second part is also finished. Now the third part, x multiplied with p, so it is xp, x multiplied with minus q minus x cube, rd multiplied with p plus prd, rd multiplied with minus q minus qrd minus d multiplied with p minus dp minus d multiplied with minus q plus dq. So the third part is also finished. Okay, now let me check what are the things which can be cancelled from here. So plus x cube and minus x cube cancelled, minus xr plus xr cancelled, plus pqd minus pqd cancelled, minus prd and plus prd cancelled, minus dq plus dq cancelled, plus dr minus dr cancelled, minus xp plus xp cancelled, plus qrd minus qrd cancelled. Anything left? Plus dp minus dp cancelled. So you can see the whole thing has been cancelled and the result is 0. Therefore we can say, therefore a q minus r plus d r minus p plus c p minus q is equal to 0. This is proved. So hope you have understood. Actually, though the calculation looks bigger, lengthy, and the sum also appears to be lengthy, but it is not the case. The sum is very easy. Only thing what I have done, I have followed the basics. Whatever is given in the question, I have used the concept of the chapter and then simplified the whole thing. Let me explain it once again. The pth term was given as A, qth term was given as B, and the rth term was given as C. So the general form of pth term is x plus p minus 1d. Here x is the first term because I I cannot take a as the first term, as the pth term is given as a. So I have taken the first term as x. So the general form of pth term is x plus p minus 1d. The general form of qth term is x plus q minus 1d, and the general form of rth term is x plus r minus 1d. Their values are given. This is the question we have to prove, that a multiplied with q minus r plus b multiplied with r minus p plus c multiplied with p minus q equals to 0. So I have substitute the values of a, b and c from here. The value of a is this one, value of b is this one, and value of c is this one. So I have replaced a, b, c and put their values there. So this is the form I have got. This is the value of a, q minus r, the first part. This is the value of b, r minus p, this is the second part. And this is c, value of c, and p minus q, the third part. After simplification, the whole thing has been cancelled. The result is 0. Therefore, it is proved that a multiplied with q minus r plus b multiplied with r minus p plus c multiplied with p minus q is equals to 0. Okay. So in this way, any type of sum, any sum based on this type is given. You can apply your basic knowledge, the concept, and do the sum. Okay. I hope after doing so many sums from this topic, you have gained a lot of confidence, and if any sum comes based on this type or based on this topic, that is general form or the general term, you must be able to do the sum. I am confident enough about this. Okay. So this is all. This much sum which we have done from the topic is over now. In the next class, we will learn about the sum of n terms of AP and then apply it to solve different types of sums. So that's all for today. Okay. Let us meet in the next class. Till then, goodbye. Have a nice day.